So what I bring along is this isotope geochemistry background, and I use this as a method to provenance where timber came from, where archaeological timber came from, that was then used for shipbuilding. So what I actually do is I take samples and I see what values they have and how I can relate it to a natural environment to match up a potential origin of materials.
In the timber project, we are using tree ring analysis. That's where I'm coming from, to examine where the timber in the past comes from, so that we can map the changes in timber trade and the changes in exploitation of timber in Northern Europe over time. But there are gaps in this knowledge, so we're experimenting with other techniques to identify timber's provenance, where the timber originally grew. Among other things, we're using stable isotope analysis, particularly strontium, to try and identify the timber's provenance. And Alexandra Rodler is carrying out those experiments.
I would go out into the field and I collect soil samples, I collect water samples, I collect plant materials that have been growing in the same area to see how that matches up. And I also use experiments for my work to see if I can differentiate the isotope signals that I see in different materials, so in, for example, the timber material, and then also the water and the soils and so on. So I go into the field and I collect seawater and I submerge fresh timber pieces into this water and let it just sit there for a long time, take it out again, and use this as an experimental material to work with to differentiate those values. When I take a sample, I focus on strontium isotopes. That's a really good tool for provenancing archaeological materials. And I separate the strontium out of this material. So whatever it is, if it is water, if it is soil, if it is plant material, I just separate it so I have strontium left, and that I analyze for its isotopic composition. And then another one is going to the field, actually collecting from areas where we know there were historic sources for the timber used for some of the shipwrecks we're working with. So I go to those areas and I collect soil and water and plant materials, analyze them also for the strontium isotopic composition, and that's what I use to make a sort of map. So it's like an overview of what areas have what kind of strontium isotopic signature, and does this relate to the archaeological timber samples that I analyze later, which is the last point of these three packages, where I take archaeological waterlogged timber and try, just analog to the experiments, I try to remove this waterlogging signal, this mostly seawater or river water strontium composition. I try to remove that so I get to the original tree, to the original timber strontium composition. I can see there is potential for this, so I can see a direction to go in, but it's still in progress.